Hi, and welcome to week 1 of our climate change and global warming class. I hope that throughout the course, if you have any questions, you can send me an email and I will get back to you as soon as possible. Now, to understand what climate change is, we first have to know the difference between weather and climate. Weather is just the conditions that you see outside today. Is it sunny? Is it snowing? Is it rainy? Climate, however, is looking at these atmospheric conditions over a longer period of time, and the minimum time that they're looking at now is 30 years. So if you measure the weather patterns over a region for 30 years, that's long enough where if you have an odd event or an outlier, it will be able to be thrown out of the data set and your data set will have more integrity. Now, in this class we're going to look at natural factors that affect the climate, like a volcano that erupts and it puts a whole bunch of ash into the atmosphere. It will block incoming solar radiation. And we're also going to look at anthropomorphic sources, and anthro is us and morphic means change. So we're going to look at anthropogenic or anthropomorphic causes for a changing climate. Now, as we look at this, we're going to analyze data and we're going to work the data using the scientific method. We're going to look at what are the sources of the data, where do they come from, how reliable are they. We're going to look at, do they tell us anything, are there any correlations, such as if I eat a whole cake every day, will I gain weight? And I'm sure that correlation would be yes, because I've done it before. Then we're going to look at, is there uncertainty in the data? So yesterday we had a 40% chance of snow here, and it snowed 100% of the day. So when you're looking at forecasting, you're going to make climate models that have some uncertainty in them, no matter what you do. And that's because we don't have a full understanding yet of the climate data or projecting it into the future. Right now we can say, well, we're putting this much carbon dioxide into the atmosphere and we're saying that it's going to cause global warming, but in the future, are we going to put more in? Are we going to put less in? So throughout the course, as we look at the models, we're going to look at the data, any uncertainty, and how we can model it for the future so that we can get the most accurate picture that we can see of what's going to happen over, say, the next 100 years. Now, let's look at history and see where we are with climate. Over the last 2+ million years, the Earth has been going through a series of glacials and interglacials. And an interglacial is just a warm, temperate period between two glacial periods. Since about 15,000 years ago, we have been in an interglacial time. So you would expect during this time that you would again have warming climate change happening. Now, over the last 40 years, we have seen the warmest on human record since we started recording temperatures. So we're seeing over 40 years, it's long enough to be able to evaluate a climate. And throughout the course, we're going to look at what has happened historically, what is happening now, so that we can use all of that data to model what we think the future climate is going to be like. If you look at figure 1.1 in your textbook, you're going to see that there are significant climate events happening all over the world. It's not just in one place. So we have to analyze all the data from the present and from the past if we're going to be able to look at what we might see in the future. Now, your other lecture is a written lecture this week, and it's about more developed countries and less developed countries. And more developed countries like the United States, we have been through an industrialized age, and we're now moved into technological age. We have good water infrastructure, we have sanitation, we have a relatively stable government. If you look at less developed countries, generally they don't have the same infrastructure that we do. They may not have access to sanitation. A lot of people living in these countries may be living as subsistence farmers, where they grow what they can to feed their family every year, and that's all they have. Well, each of these are going to have a different resiliency to a climate change. So if we have an event like Hurricane Katrina, we had the resources to be able to go down there and try and help people. and deal with it as a nation. If you have a climate event such an extended drought in a country in sub-Saharan Africa, there aren't places that they can go. The governments aren't always that stable to be able to provide food. So how these different countries or different areas deal with climate change events, you're going to see there could be a radical difference. All right, so the question is there a link between industrialization and global warming? And global warming actually is stating that we humans have put enough greenhouse gases into the atmosphere to cause the world's global average temperature to rise. And right now they are measuring that over the last 100 years that the temperature is rising about 0.3 degrees C for every 10 years that we're seeing. So are we being able to affect climate change? Well, when we burn fossil fuels, oil, gas, and coal, we emit carbon dioxide into the atmosphere. And this is important because when you have, in the atmosphere, it's mostly oxygen and nitrogen. And when the radiation comes in from the sun, it doesn't react to it. It doesn't emit it back, and it doesn't absorb any heat. So when we have radiation coming into the Earth's surface, some of it, as it's coming in, will bounce back out into space without ever having reached the Earth's surface. Some of it will reach the Earth's surface, and there it can either be absorbed or it can bounce back. Now, if you've ever walked on a hot asphalt in the summer, you'll know that darker surfaces will absorb heat and lighter surfaces will generally bounce it back out. Well, throughout this course, we're going to look at the troposphere. And the troposphere is the layer of our atmosphere that ends at about 5 to 10 kilometers above the surface. And this is an important boundary because there are two kinds of heat that can be collected here, two mechanisms. So if we have at the top of the troposphere these carbon dioxide, which is really good for absorbing heat, so is water vapor, methane, and nitrous oxide. If the energy from the heat from the sun bounces off the Earth's surface and goes back up to these molecules, then they will actually absorb the heat in them. And as a result, it will form like a security or insulation blanket between the Earth's surface and the top of the troposphere. The second mechanism for gathering heat in the troposphere is convection. Now, when you have warm, moist air, it expands and it rises. And as it rises, it gets near the troposphere, it actually cools down and it collapses and it comes around. So you have this convective movement of heat that moves through the top of up to the top of the troposphere also. So through these two mechanisms, we're going to look at both of them and see if we can gauge how much warming is happening globally because of each of these. And is it because of our greenhouse gas emissions that we see a trend in the fact that the global average temperature is rising? So that's all for week 1. I hope that it's going to be a great week. And again, if you have any questions, just send me an email and I'll get back to you. Thanks.